Induction hardening. So one type of surface hardening process. So this is induction hardening process. Use heating the steel or cast iron. Okay, using the heating the steel or cast iron material. This is workpiece or steel or cast iron in high frequency electric current. Okay, the heating the material by high frequency electric current is called is a induction hardening process. In this induction hardening process, the high frequency AC current, alternating current is supplied, okay, from the high frequency generator, okay. So high frequency AC current, so this high frequency AC current generate the high varying the magnetic field, okay, they varying the magnetic field. So that magnetic field produce the eddy current, okay, that magnetic field produce the eddy current. So on the this eddy current is induced the heat to the component, okay, that eddy current is induced the heat the component, heat the this workpiece, to heat the material for above the upper critical temperature, okay, the heat in the material above upper critical temperature. Then after quenched the water, okay, after quenched water, the surface is simultaneously quenched, the water jet is passes through the holes in the induction unit, okay. So this water, so cooling of water using water, so this is the water jet, okay, provided in the induction unit, okay. This is the water through induction pass through the water jet, okay, to the workpiece, okay. So the coil is provided in the induction unit, okay. So in this induction hardening process, in the frequency range of the is 1000 hertz to the 1 lakh hertz, okay. So depth of the hardening for this process is 0.5 to 6 mm, okay, around depth of the hardening is 0.5 to 6 mm, okay. This is induction hardening process. So in this process, the induced current flow is inversely proportional to the square root of induced frequency. Okay, the induced current flow is inversely proportional to the square root of induced frequency. The time to hit the component is mainly take 2 to 5 minutes. This is the very limited time, load time, okay. So time to hit the component within 2 to 5 minutes we reach the above the upper critical temperature. Then fine Martens's structure is produced due to the heating and cooling is rate is very fast, okay. We can get the fine Martens structure, so due to the heating and cooling time is very fast, okay. So mainly cooling and heating time is only 2 to 5 minutes only. So this induction hardening process applicable to the gears, tool drives, wrist pins, crankshaft bearings, rail, machine tools, cylinder liners and pumps component. What are the advantage of this induction hardening process is, so if you are large number of pieces, large number of assembly components, we can hardening the only small region of the component also, okay. So if we have if we have assembly of the component, so you want to hardening hardening for the small size of specimen or small area. So using this process we can increase the hardness, okay, without affecting the other region, okay. Also, okay, small region also you can hardening without affecting the other region. So using the rapid heat and holding time is less, so increase the production rate also. So heating time and cooling time is very less, so you can increase the production rate. This is a process applicable for the mass production. So what are the advantage disadvantage of this process is, cost of the equipment is very high, so irregular shapes not suitable for this induction hardening process, okay. So in this process irregular shape means it is difficult to hardening, okay. Thank you. This is the induction hardening process. Thank you.